All right, guys, the combined gas law. So remember the combined gas law, this includes all of the factors. So pressure, volume, and temperature. All right, so this example problem again comes from your PowerPoint. So a gas occupies a volume of 458 milliliters at a pressure of 1.02 atmospheres and temperature of 295 Kelvin. So when the pressure is changed, the volume becomes 477 milliliters. If the new temperature is 330 Kelvin, what is the new pressure? So again, this combines all of the factors. So your formula is going to include pressure, volume, and temperature. So for the ideal gas law, it's going to be P1 V1 T2 equals P2 V2 T1. Okay, so first writing out everything that we are given in the problem. So what we're given in the problem, we are given the first pressure, that is 1.01 atmospheres. We are given the first volume, that is 458 milliliters. And we are given the first temperature, that is 295 Kelvin. So what we are solving for, which we are told in the very end, and we can just go in order of what we should be filling out. So P2, that is what we are solving for. Okay, so that's our only unknown. Other things that were given in the problem. The second volume is 477 milliliters, and the second temperature is 330 Kelvin. Okay, so again, just plugging all of these numbers into the formula that you need for the combined gas law. So it should be 1.01 atmospheres times 458 milliliters times 330 Kelvin, and that is going to equal P2, again, that's what we're solving for, times the second volume, that's 477 milliliters, times the first temperature, that is 295 Kelvin. Okay, so if you multiply all of this out, so first you would multiply 1.01 atmospheres times 458 times 330. And then you would multiply out 477 times 295. So if you did all of that, you would again divide everything on this side and divide that same number on this side to get the second pressure by itself. And that would come out to be 1.08482 atmospheres. So for our sig figs, and going back to the original problem, we have 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs, and 3 sig figs. Okay, so we need to reduce this number down to 3 significant figures, and that would be 1.08 atmospheres. Actually, no. Our final answer has 2 sig figs, because 330 only has 2 sig figs, okay? So our second pressure would be 1.1 atmospheres, okay? Because remember, so our first 2 sig figs would be 1.0, and then you have to look to the number to the right to see if you need to round this one up or down, and because 8 is greater than 5, then you round this up to the next digit, so it would be 1.1, not 1.0, okay?